or interstory drift. Wow. Okay. So now we're going to look at an example, and I'm going to switch it over to Paul.
All right. You're still driving. So one, what example we got? We got first
your Altair.
Okay. So one example of what Gabriel was just talking about is in the general notes. If you can blow that, if you can blow that up a little bit. So I highlighted some areas that people should be familiar with when they're looking at the structural general note sheet. And I clouded this, and this concrete mix schedule right here is important for AWS for all of the slab anchors, slab on grade. I didn't highlight the shot creek, but once in a while you'll get in a situation where if they fill something in, AWS will want to know how strong the grout is. You can pan over to the right there. So this table here again is the thickness schedule of the studs. This is again something that we're all familiar with, but you can see that the person who's going to supply the studs, their thickness can vary throughout the entire project. And anywhere we attach, it is typically going to start with a minimum of 16 gauge. And I can guarantee that if you don't communicate this up front, you're going to have 20 gauge or even 22 gauge that the stud sub is going to carry, because he's going to carry obviously the thinnest he possibly can because it's the cheapest for him. So we have to be really careful with that. And then in places where we need thicker studs, we need to make sure that we tell the contractor that. So this is an important table.
And then it was just this one as well.
Yeah, that one down there. And that gives you some basic information on the story drift and what kind of they're expecting. And then this chart here, you would want to go over that with Kendall and John and jumpstart there to figure out how to write RFI number 1.
Right. So I guess that one of the main takeaways is you make sure to look at these sections, and even if you don't completely understand them, you know, you can probably, if you look at them side by side to RFI number 1, just making sure that the information that's in here is also in RFI number 1. I think that's helpful as well.
Right.
So I will move on to the next slide. Okay. So now the second pillar of success would be understanding what callouts mean and how to read the floor plans. So a sheet, normally in the structural drawings, one of the first few pages, initial pages, are something that's called the sheet index, legends, and abbreviations page. It has a lot of useful information that'll help you kind of understand what's going on in the floor plans. Another thing that I wanted to kind of highlight is the fact that all the lines that we see, you know, have a meaning. That's true for both our drawings and structural drawings. In structural drawings, particularly, all the lines and the dimensions pulled are typically to the center of the framing members, which are the columns and beams. So in this, this is just a snippet of the legends and abbreviations page. So, and you know, these little notes indicates the slab elevation. This indicates a step in the slab. These are types of connections which we're not really concerned about. If you're curious, this is how to determine the size of beams. So typically this number, the 50, is the pound, the weight per lineal foot, and this is the depth of the beam, the number of studs. If a beam is below the typical top of steel elevation, it will be noted as such. So -4 + 4. This number is just the camber, which, anybody know what the camber is? Any civil engineers? Anyway, the camber is basically just a curve on the midspan of the beam, which is used to resist heavier loads. So once you pour concrete on top, if it's already curved, it will not bow downwards. It'll be normal. So that's what that means. So now we're going to go to an example. Which was on my other screen. Oops. So this is the sheet that I was talking about. You know, contains all those legends. It tells you what the abbreviations are. So if we look at a floor plan, for example, just starting with the level 2. So in a typical structural drawings, as you can see, there's a bunch of lines that is always dimensioned to the center line of the framing member. You can see here they put in the curtain wall in halftone. So these dimensions that they show, for example, on some of the edges where they dimension, you know, from a line to the edge, that would be from the center line of the column to the edge of slab and such. And if you're ever curious as to how to, you know, size these, if you type this on Google, it'll tell you the exact size of the beam. So then now we're going to go to the third one, which is understanding kind of how the structure supports or interacts with our system. So what you want to do when you're looking at structural drawings is you want to verify the slab edge conditions to see how you know, they're supporting or conflicting with our anchors and embeds. You want to check that the framing members help support the window head and that they allow for installation tolerances. And you want to check that the perimeter conditions are accurately depicted in our drawings. I know oftentimes we like to omit certain elements, but I feel like they're important. And this is just a little isometric of a typical slab edge. So you would have the beam, the edge form, concrete, corrugated deck, and the rebar reinforcement. So now we're going to go to another example by Paul, which are some of the details from
Yeah, so when reviewing structural drawings, you'll see that like the bent plate, there are certain parts, like this was 1180 Main, and what you're seeing is that in some spots there was a bent plate up there in the upper left corner, and on the right side they just had an edge form. And so the important thing is to know where those things occur, you know, where they're planning on using it, because that'll have an impact on your system. And also that could go back to bid. If we were looking at to use that bent plate as an attachment method, you'd want to start looking at what size is the bent plate, how thick it is, what kind of loads can it handle. There's a little sketch down below that shows just a standard hook with a little piece of rebar in it. So these are the kinds of things that you'll want to look for when you're looking at your drawings and how we interface with the edge of slab. Go to some of those other clouded areas with that shows our system. So in situations like this, you'll want to take a look at exactly what's happening. Like they show our system, and here they show precast, they show all of the studs that they're going to put around. They show the relationship to the slab. So these are, most of the time you're going to see the window system. It could be in a different layer, but it usually most of the time is in there, and you can see their interpretation of where your window wall is. And then you can make sure that when you're going through working with the draftsman, that you can make sure that it's in the right spot. Like Mike or somebody may have our system offset a little more. We would have to know what that means when we do that. This example down here, this is a canopy that we have. Knowing that exact size of tube is important. So we got to make sure that where we are placed, our system within it, you can see that it's not centered on the tube, because if it was, it would literally be hitting, our mullions would be hitting the edge of slab. And I originally, when the job was drawn, I think the placement of that HSS was in question. Where is it exactly? So here you can at least see and verify that, well, the structural guys had this literally in this spot, and here's where our window system is supposed to sit in relation to that. And there's just a few more examples of that. And you can find them all throughout the structural drawings. It's just real important. The real big takeaway here is anytime you see our system in the structural drawings and there's structural steel around it, the important thing is making sure that we know exactly what size of steel that is, what it is exactly, and where they plan on placing it.
Right. Perfect. So now we go back to the last slide, which is understanding, common mistakes and lessons learned. So common mistakes that we sometimes make is generic notes in our drawings calling out size to be verified or just varies, not sizing those members correctly, assuming that the architectural drawings are 100% correct and in line with structurals. That's not always the case. And showing structural members as what we need without doing the due diligence of sending a confirming RFI or properly documenting. And so an example of that would be another attachment here by Paul.
So on 1180 Main, if you can blow that up a little bit. On 1180 Main, what we had was we drew and clearly called out an HSS tube, and we called it out an 8x3. So I went back and checked the structural drawings at where that's located, and it's clearly sized as a 9x3. So we continued, and our drawings went through both all the internal reviews, the external reviews, structural guys on the phone. Nobody said anything about that tube not being an 8x3, but it was a 9x3. So that note that I highlighted in pink there, size to verify, really kind of killed us, because we were going saying, hey, why did you guys install a 9x3 when we clearly have an 8x3? And their question is, well, hey, you have size to verify, right? So I went back to the structural drawings, and on the floor plans, it clearly shows that tube as a 9x3. So I kind of dashed in the actual size of the tube of what it would have been, and I would have had to cut down every single one of those bottom panels in order to make this thing work. Thank God they deleted that whole scope, so we didn't have to do any of that work, but it could have been a bit of a mess, and there was quite a bit of that cladding to do. So that would not have been fun. So again, the lesson here is anytime you see us anchoring to a piece of structural steel, we need to make sure and verify exactly what the size is and make sure it's located in the right spot. And that's the structural drawing I clearly called out an HSS 9x3.
And then I feel like there was another example. Here's the other one.
Yeah, so this was an example on 100 Altair. We just had this, we had a jumpstart detail that we started with, and it just shows basically concrete underneath there in yellow underneath our sill runner. So when Mike and I were really getting into the drawings, we started looking at some of the details, and we noticed there's a curb, but we couldn't. He didn't see the curb in the architectural drawings. So I said, hey, let's check out. Let's look at the structural drawings. And sure enough, the structural drawings actually show the curb. They show the placement of the curb and where they anticipate our system sitting on that curb. So you can see that the back of system lines up with back of curb, and the curb is chamfered, which, so this is going to be reality. I think too often in the drafting world, we sometimes draw what's convenient or what we think we know. If we don't chase it down, it can be different. And so we ended up, I don't know if you have that other detail. So that's the detail that we do have now, because that's reality. And you have to remember that people don't build off of our drawings, they build off of the contract documents. So had we thought that this was a flat curb or went further back, our system or layout could have been wrong, and our drawings could have been wrong. So
right. So I think it's kind of an instance where we really focus on the architectural drawings and what the architectural drawings show, and then the steel guys focus on the structural drawings and don't necessarily look too much at the architecturals. And, you know, if we don't cross-check, then we end up with building something that doesn't match or doesn't necessarily align. So now the only other thing that I wanted to do, so that's it for slides. But what I wanted to do is maybe just do a little exercise and go through some of these structural details and trying to, oh, I don't know who the host is. Oh, there we
Lisa.
go. So going through some of these details on 751 Gateway, because it's the job that I've most recently looked at steel, and trying to kind of really understand at least what we're looking at, and some of these details can be a little bit hard. So what I like to check is kind of the perimeters, right, where we show curtain wall here. In this case, we're showing we have curtain wall that's here on the second floor. So I would just go to one of these section details. So this would show kind of the typical deck edge details. In this case, it's for MEP. But I mean, I'm assuming most people know, you know, understand what this detail is showing, the length, and then the schedule and stuff like that. I know that some of the, for example, in this case, when the slab cantilevers 2'7" or a certain distance over the beam, then they have to add some sort of reinforcement. So this would be an angle. So if you have some sort of outrigger or something, you know, you might want to watch out that it doesn't conflict with the angle. And then looking at typical steel details. So I know for sure the first time that I looked at some of this stuff, it was really overwhelming, because I was like, I don't know what's going on. There's a bunch of bolts and stuff. And then, for example, I'm trying to find the one at the roof. For example, this detail, I was like, whoa, there's a bunch of stuff going on. But clearly I know that my window's here, so I kind of need to figure out, you know, what's going to happen. I know that at this roof line, we have some embeds. I wonder if this conflicts with the steel post that they're showing. There's a bunch of stuff happening. So it's not as complicated as it may seem. I know when you initially look at it, it seems like there's a lot going on. And this is kind of like what the detail looks like or what it will look like actually. So you have sort of the roof level, you'll have the slab, we'll have you know, this T that's going to support the slab and support this tube. And then once we put our system in front of it,
Oops.
sorry, let me just do a section. Zoom sucks, it makes everything slower. So it's just, you want to understand what's going on and to make sure that there's nothing that's kind of clashing with your curtain wall. In this case, we had the steel sub move the tubes to miss the embed, but because there was multiple instances where this tube was directly behind the embed, and if this tube is coming out from underneath the steel, then it was just going to be a nightmare to install and to detail. So stuff like that. And I think that's pretty much what I had. Sorry, it wasn't as exciting.
On that example, Gabriel, I have a question. I think it's at like 2 foot max to that HSS. How would you go about figuring out the exact dimension to verify that that post is, you know, what it should be? If it's a 3 inches away from backup system, or it looks like it's not on base of slab, but
Right. Yeah, so it would show on the framing. So if we go to the roof framing, we would actually see, sorry. So we see the tube. So I guess it would be a matter of kind of laying out, you know, from this center line dimension, which is grid, what is that? Grid A, doing maybe like a 2-foot offset and seeing if it lands for this tube, and then maybe offsetting an additional dimension or dimensioning from the tube to the back of system, making sure that's 3 inches. So that's how I would verify. But I mean, even just looking at the floor plan, you can see that we have the vertical mullion and there's something right behind it. And then when you go to the detail, which is the one that we showed, it's that complicated thing.
is that how you would check it, Paul?
Well, I was gonna say another way to do it is that same floor plan section, you should go to the architectural drawings, because the
Mhm.
architectural drawings will give you from column line to face of system, which
Right.
typically their face of system is to glass. And then if you use that dimension, you could work back to this one. So let's say it's, I don't know, just 3 feet, right? Let's say it's 3'6" or something. So if there's a dimension from grid line to face of system, you can work your way back.
But we would pretty much still, like, for me, I would look at that and try to figure out where it's at, but still RFI or verify the dimension. in
If you're
accordance-
unsure, yes. If you're unsure, then yes. If it doesn't look like these architecturals had a
an exact
dimension
dimension,
to
right?
face a
Yes.
system, but that's how I would do it.
Well, even if I have face the system, I'm not getting an exact dimension to the center line of the HSS. So it still want to verify that dimension from grid A to center line of HSS.
Right. You could write an RFI, but I would write the RFI that would looking for the solution you need.
Okay.
But I mean, you could start with what you know, which is whatever is showing on the section detail. So just and try to work your way backwards and see if it makes sense. So, you know, from grid doing the 2 foot to the center line, we know this is a, does it call out the size of the tube? It probably does on plan, but oh yeah, it does 6 by 6 by a quarter.
Got it. Yeah, okay. And then one more question on the typical structural plan. They always show the dimensions to grid, but then there's other beams in between without any dimensions. Is that just assume that they're spaced equally within the opening?
You're talking about
Like
like,
from grid, yeah, what's that, 6 to 5?
mhm,
We got those 2 W24 by 55s
right.
without any dimension given. And then there's others,
Yeah,
right?
that's a good one. I think, yeah, these are, I would assume that if you count 2 in between, they would be evenly spaced along the 33 feet.
So at 11 feet. But I think along the other direction, you have some that don't look like they are evenly spaced.
So for example, you're talking about this direction, the horizontal direction.
Mm-hmm.
Well, in this case, you're given most of these dimensions, I think were, yeah, you see, like, for example, here, 11'3", then 8'3" for this. And then you
Yeah,
have
just
the weird one sometimes.
anybody know, is that like assumed or how
Well,
did,
typically, I don't think it would be assumed, because if you stay on that area right there, you look at that that oblique corner right there, that you have a grid line dimension, but you got those W21 by 44s. Those
Mhm.
are not evenly spaced.
right? Yep, that's a great example right there.
So
But, yeah.
if that impacts you
Oh,
and you need to know, that would just be an RFI.
okay.
Yeah.
Because I don't think that, yeah, it's typically, like in most areas, you're going to see that they typically, it's usually evenly spaced, but in there, stuff like that, it's not going to be. So you'd have to RFI that.
Yeah.
Okay.
But I want to say that when they are not evenly spaced, they do try to call out a dimension like this one, 4'4¼ but then this one, you'd have to, I have no idea. I don't
Right.
see a dimension for that one.
Okay. Yeah, I always wonder how the structural steel guys dimension from the structural drawings.
Well, on that example there, there's a dimension from a grid to grid. And if you minus that 4'4¼ there's your distance between that one that's on C5.
Right, but then for
You can
example,
get to it
one
that
on the
way, right?
left, right? You
Yeah.
have the 21/44 without a dimension.
Yeah, there's one in the center that's not. And as you can see, it's offset from the next quadrant up.
I'd probably just scale it.
Yeah, just wondering if there was a general rule or way or.
Well, I always try to use their dimensions, and if I can't come up with it, I try to scale it, and then I send an RFI.
Okay.
Have them confirm it.
Right.
Thank you.
Like even, for example, at this corner, I mean, this is kind of a skewed corner, so I have the dimension for this member running horizontally, but this other one I really don't know, unless I might, I go to one of the details that are showing the perimeter, and then maybe it'll show the offset from slab edge to the center, and then we can work backwards and verify it like that. But that's pretty much it.
I really liked Paul's example with us dimensioning a steel beam a different size and what the structural show.
Right.
Because that happened to me on Matilda.
Oh,
and
did
I
it?
feel like
Same
that's
kind
like
of
a
thing?
huge one. Yeah, well, we're wrapping the beam, but the architect determined the dimension of the fascia part that wraps the outer beam canopy.
Mm-hmm.
And in order to make that happen, we had to draw a smaller steel tube. But, we just drew the one that would fit in the size of panel that the architect wanted, instead of like making a big deal out of it and raising your hand and being like, hey, we changed the size of the steel here in order to get, the panel fascia dimension that the architect wants. We just put the small little note that said verify, and I didn't verify it, which I should have. It was just something that I missed. So I think that that's like a huge one, especially anytime we're wrapping steel or cladding steel, that we pay really close attention to what the structurals are showing, and if we're varying from it at all, we should RFI it.
Agreed. And I think too, it's once the drafter will put verify on there for their convenience, and it's a note, and they're thinking that, well, somebody will verify this. And then we go through all the submittals. Nobody says anything about it. We assume, well, it's verified because no one said it wasn't right.
Yeah.
Right. But then no one confirmed it was right. So it'll always come back on us. So it's never something we can go back and say, well, you didn't mark it up.
Yeah, especially because our shop drawings don't really mean anything to them, because the contract documents that we're bound to are the structurals and the architectural. So if we show a different size, even if we put a note that tells them to verify it, it doesn't matter.
Right.
Exactly.
Yeah. You gotta like RFI everything.
And I think it goes back also to the whole thing of like, the architect is not always right. And sometimes even though they're working with the structural, the engineer record, and they're producing these drawings for them, the details don't match. So for example, on this job, we're clearly showing stud framing at the head of the window, right? Yeah. And then that's what we drew, but when we went and verified, it's actually a steel angle at the head of the window that's like running across. So it's a complete disconnect.
Yeah.
If you don't do the due diligence, because probably the architect isn't going to do it for you, then you're going to go out to the field, and if this is out of tolerance, like there's no way you're going to move it. It's going to be a nightmare. So
And if you do see discrepancies between the structurals and the architecturals, and you get them to confirm what ones to follow,
Correct,
I
yeah.
had it where they say, no, follow the architecturals. You want to make sure you have that in writing for,
Right.
Just
8
submit an
months.
RFI.
RFI documentation,
Yes.
all of that.
Yeah, because they won't remember telling you.
Yeah, that was something that I really learned from Matilda was, and I think too, it's just the difference of, I'm so used to working with DevCon as opposed to level 10. But, you know, DevCon will recognize our shops a little bit more than it seems like level 10 will. So I just learned that if there's ever any differences, or, you know, if there's any discrepancies between architectural, structurals, or our drawings, just RFI everything.
Yeah, I would keep an eye on that thickness of the tubes too, because I would never show a drill flex going into a 1/2-inch piece of steel, because you'd be drilling all that. Like, you're probably lucky that that got removed, because you would not have enough hours for a field guy to pre-drill steel clips.
Travis, man, you gotta clean your camera. It looks like you're like fogged up to the max.
He is fogged up.
It's that heavy breathing he's got going on. Hi.
Oh, that's
That is being
disgusting.
recorded. I'm sorry, Travis.
Oh, I forgot to. I'm sorry.
I was gonna say, can you remind y'all, this is being recorded.
Stop recording.